So now we talked about being careful not to create bias. That was last time. Now we just talked about all the different types of data we could collect. We'll be talking fairly soon about your project. I told you there'll be a project this semester, and you're going to go out and collect data, and maybe you're going to get some categorical and some quantitative data. So you might be asking people their favorite movies and their heights, or how much money they make, whatever it might be. How you collect the data, you have some options. One of them is that you could just go out and do what we call an observational study here on the top of the page. You just go and you observe whatever it is you're looking for. Every semester I have someone who chooses to do their project on cars. And I once had a student who went out here and stood on the corner and just counted. This is how many blue cars went by, this is how many white cars went by, this is how many trucks, this is how many SUVs. I don't know if it was the most interesting project she came up with, but that's what she wanted to do. The point is, she was observing. She just stood and observed whatever her sample was going to be. So her sample was the cars that happened to drive by that morning between 9 a.m. and 10 a.m., whenever it might have been. So she was doing an observational study, just watching, looking, and recording what she saw. She wasn't interfering with the cars. She wasn't, jumping out on the road. Hey, stop! Let me ask you a question about your car, right? Let me tell you something and then get some information. So observational study is just observing. Whether you're actually observing with your eyes, or you're looking up some data online, or you're handing out surveys and getting information back, you're just observing. You're not interfering with it in any way. The other way is an experiment. Typically this happens all the time in science. Some of you have had science classes before, where some treatment, they call it treatment, is applied to the subjects. The person or group does something to affect the outcome. So let's say I think I've got this new drug that's going to help cure cancer. I really wish I did. I'm going to take this drug and this, what we call a placebo, something that really does nothing, but you can't tell the difference when you look at them. And I'll administer one drug to some people and the placebo to others and see if there's any difference in the results. So I've now deliberately affected my results by putting people into one group versus the other group. So I've applied some treatment now. So now I'm not just observing, I'm doing an experiment. I had a group once who did their project on dogs. And they wanted to know, one of the girls worked at a vet's office, and they wanted to know how they spoke. It was actually next group. How they spoke to the dogs, if it affected how the dog reacted to them. So if they came in and were kind of rough to the dog and spoke kind of harshly, how would the dog react to them versus if they were very sweet and kind and gentle with the dog. So, and it was like every other dog, they would go through and speak to it differently to see how the dog reacted to them. So that, again, was an experiment because they were doing something to affect the outcome, as opposed to just checking to see how each dog acted when it came in. That would have been different. Clear the difference there? Depending on what you're trying to find out, you might do one versus the other. Okay, these next two things on the list here, simple random sample and random sample, take 2 minutes to read them, and then I'm going to discuss them. And these are two of the hardest things for anyone to wrap their brain around. So read them first, I'll shut up, and then we'll talk about them. Who thinks they can explain the difference between those two things? Ooh, silence. Stephanie. You think you could? Maybe. Ooh, I like a maybe. Is there anyone who thinks they sound pretty much the same? Is that your hand up? Yeah. They sound kind of the same, don't they? They're almost the same. And this is why this is one of the hardest things for stat students to get. I work in the lab so many hours every semester, and even if it's not my students, this is the most common question I get in the math lab. It's Jill, I don't know if this is a simple random sample or a random sample, and I still don't think I know the difference. And I spend all day for the first couple weeks telling people what the difference is between those two groups. Is your hand up?
Isn't simple just like out of a sample instead of a population?
Both of them are samples. So both of them are you're collecting a sample out of your population. So let's say we have all LMC students and we want to collect a sample of some LMC students. So then the question is, once you get that smaller group, is it a simple random sample or just a random sample? We're going to talk through it, don't worry. I'm going to use an even smaller population from our discussion today. So let's assume that you guys are my population and I want to select 4 of you. That'll be my sample of size 4. Okay? So we want to discuss what it means to be a simple random sample versus a random sample. We're going to talk about simple random sample first. If I take all your names, I put them all into a bowl and I mix them all up here, I got my big giant bowl here, and I reach in and I pull out 4 names. Let's talk about that. It says here, a sample of n subjects, I chose 4. N was my 4, right? My 4. We're going to have a sample of 4 subjects that's selected, so every possible sample of the same size, 4, has the same chance of being chosen. So I'm going to reach in here and pull out 4 names. Is it possible that I'll happen to get these 4 people who happen to be sitting in the front of these rows right here? Could I get all 4 of these? I could. Am I just as likely to get the 4 people that are sitting in the back over there? Same chance, right? Or maybe I'll get 1 from over here and 2 sitting next to each other in the middle and 1 over there. There's no group that's more likely to happen than others. We agree? If I just put them all in a bowl and pull them out? That's the best way to think of a simple random sample, is imagine if you put everybody's names or numbers into a bowl and you pulled them out. Is that what you're doing? A lot of times the description may not say that's what we're putting it into a bowl, but the description is very similar to comparing it to that. That's what makes it a simple random sample. Every possible group has the same chance of being selected. Those are my words to go along with the specific definition. So what about random sample? How's that different?
Because it's individual, like the last one we were talking about a group, and this one says individual member from the population.
Right, so each individual has the same chance. Okay, so let's talk about that. In my example of the bowl, do you all have the same chance of being chosen out of my bowl?
Yeah.
Yes. See how they sound the same? So the simple random sample that we just discussed is a random sample. Random is a little bit looser. It's a very specific one. If I pull names out of a bowl, you all individually have the same chance of being selected. But also every possible group could come out of my bowl. So it was a random sample, and in more particular, if I use my bowl, it's a simple random sample. I'll give you an example of something that's random but not simple random to help you see the difference. Imagine for the moment that every row has 4 people in it. There's 10 rows here, say, 4 people each. I'm going to use my little random number generator on my calculator, and I'm going to pick a number, and my sample's going to be everybody in that row. Do you all have the same chance of being selected? If there's 4 in each, pretend there's 4 in each, otherwise it doesn't work. If there's 4 in each row and I pick a number between 1 and 10, is there anybody here who's more likely to be chosen than somebody else? No, right? Because I'm just as likely to get this row of 4 than I am to get that row of 4. You're not sitting over here going, oh great, my chances just went down. Every individual person has the same chance. But will I ever get a group with these 4 people in it? Not doing that technique, right? Because I'm taking a whole row. Either I get this row or I get this row. These best friends forever are never going to be in the same group. So it's random because every individual has the same chance, but not every group could happen. That's why it's not a simple random sample. I need someone to ask me a question now. If you don't ask me now, you're going to be asking when you start doing your homework. Just everybody in the lab asked me this question. Yes?
So just to be clear, the simple random sample is more about a group, a selection of a group size, and then the random sample is individual chances of being selected.
You're correct, except that the simple random is also random. So in a simple random sample, every individual has the same chance, and every group has the same chance. So you're right, it is more about the group, but it's not ignoring that first part. Random just means every individual, and simple random means every individual and every possible group. Does that help? Mm-hmm. Other comments or questions? I see some of your heads spinning like, I still don't get it. We'll beat it up till we're sure we're kind of getting it. If I gave you a list of a whole bunch of scenarios and asked you which ones were random and which ones were simple random, do you think you'd be able to tell the difference? Yes.
So simple random sample has to have 2 criteria.
Yes, I like the way he says that. 2 criteria for simple random. Every individual has to have the same chance, and every group has to have the same chance. That's what makes it simple random sample. And the best way to recognize it is, can you compare it to putting everybody into a hat and picking some out? Because once you mix them all in there, every possible group could come out. Once you do something to lump people together, like I put you in rows, all of a sudden you've restricted the groups. And that's how you can tell it wouldn't be simple random anymore. Other comments or questions about that one? This is the hardest thing to really own. Always go back to, I like the way we're discussing this, 2 criteria for simple random, every individual and every group, and it can be compared to pulling names out of a bowl. All right, so then there's sampling methods, how you get your sample. So say I wanted to get my 4 out of this group again. I want to sample a size 4. There's a lot of different ways we could do that. Some are more effective than others. The best case scenario is to have a simple random sample. Best case, but simple random samples are hard. For this group, it wouldn't be so hard. There's only 40-ish of you, so I could put your names in there really easy and pull them out. But if I'm looking at the entire population of the US, getting a simple random sample out of all those people would be pretty challenging. Right? I mean, how am I going to do that? Take my whole population, put everybody, I don't know, some people don't have, what if I use social security numbers and a computer? Maybe that would work. Some people don't have them, some people have 2. Some people are, it'd be too time consuming. So there's a lot of different techniques we use to get decent samples. One of them is called systematic. This is the easiest one I think to understand. You pick some starting point and you pick every k. And the k just could be any number. Like I'm going to pick every other person or every third person. So maybe I'm going to roll this invisible die I have here and it comes up to be a 5. So I'm just going to go along and count every 5th person's going to be in my sample. 1, 2, 3, 4. Okay, she's in my sample. 1, 2, 3, 4. Okay, now I've got her. I'll just keep counting, and every time I get to 5, that person will be in my sample. Is that random? Does everyone have the same chance of being in my sample? If I do that? If I pick every 5th? We didn't know it was going to be a 5 in advance. I see some yeses and some nos. And so I have no clue, Jill, what you're asking. Are you saying yes, or you're without, you have no clue? You think it is?
I think you have a good chance. Like everyone has the same chance because you didn't select the rule beforehand. You didn't organize students in a way that would benefit your sample.
Yeah, I didn't really organize you in any way. And before I roll my die and happened to get a 5, you didn't know what number I was going to roll. So I could just as easily as I'm counting through here land on this student as I could on her. I mean, you don't know. If everyone has the same chance. Once I pick the number, obviously that changes because it depends on where you're sitting. But it is random, actually. Systematic is random. Because once you pick the number where you're sitting, you're just as likely to be sitting on the 5th person as you aren't. What about simple random sample, though? Would that be a simple random sample? I quite no, is what I hear over here. Why not? Who was it that said no? You were right. Was that you, Michaela? No? Look at it, that wasn't me.
Well, because you can't get every group and every group is possible.
Because you can't get every possible group. If I'm picking every 5th person, and she happens to be number 5, Christiana can't be in her group because she's not going to be number 5 because she happens to be sitting right behind her. There's no way to get a group, say, of everybody in this row. So every possible group. Yes, every person could end up being the 5th, but not every group could be because of you're already all sitting down. So by going systematically, you can't make it simple random sample. Convenience sampling. Selecting data that's easy to obtain. Well, I need a group of 4. I've just decided that I'm taking these 4 people right up in front because they're closest to me and I can hand the papers quicker. That's a convenience sample. I picked these 4. It was easy. It was whatever was convenient. When people send out surveys, not only is it a self-selected sample like we talked about last time, it's also convenient. I'll just take whatever information I get. Most of the time, people use convenience samples, but statistically, they really aren't very accurate because you're just using what's convenient. If I was trying to survey LMC students in general, the whole population of LMC students, I might choose you guys as my sample because it's convenient for me. You're here in this room and I'm talking to you. But do you represent all LMC students? No, I mean, you guys are actually very similar in so many ways. You take classes in Brentwood, not all LMC students do. You are eligible to be in statistics, not LMC students are. You are able to take classes in the mornings, not everybody is. So there's all these things that you have in common. You're all enrolled in my class, not everybody is. So there's all these things you have in common that the general population doesn't. So that's just a convenience sample. I could find out, the average GPA in this room, but it shouldn't necessarily represent the whole population because you are all a different group. You don't randomly represent everyone. So convenience sampling is what happens most often, but is the least telling in terms of reality. The goal is to always have a simple random sample or something close to it, but it's very hard to do. Stratified. Stratified sampling is when you divide into groups that share some characteristic. Doesn't really matter what the characteristic is. I could divide you into groups by rows like I did earlier. I could divide you into groups by last name. Just take the first 4 people on my roster, the next 4 people on my roster. I could put you into groups by height, or by where you live, anything you want. And then, so you divide it into smaller groups, and then a sample is drawn from each group. So let me talk about this because the next one's going to sound similar again. So for the sake of ease, I'm going to say I divided you into groups again by rows. And I'm going to select one person from each row to be in my sample. So I'm going to come over here and I'm going to flip a coin or roll some dice and pick one of these ladies over here. I'm going to pick one from this row, one from this row, and so forth. That's called stratified. I have some groups of whatever the groups might be, and I pick some or one or more from each. That's stratified. Now, is that random? Especially if my groups are exactly the way you're sitting today. So these are how the groups are. I've got this first row has 3 people, 4 people, 5 people, and I'm going to pick one out of each row. Does every person here have the same chance of being selected? If I'm choosing one from each row.
Yeah.
Yes?
It's not assigned seating.
It's not assigned seating. Okay, so let's talk about it. I'm going to come over here to your row. I'm going to pick one of you. What's the chances that I get her?
1 and 3.
1 out of 3 is her chance of being in my group. What about her?
1 out of 4.
Uh-oh, she's got a 1 out of 4 chance of being selected. Do they have the same chance of being selected? That's not random then. Remember, every individual has to have the same
You get
chance?
2 groups, right?
Say that
You
again?
get 2 groups.
Right. I have 2 different groups that aren't the same size, so you don't have the same chance.
So there's 2 criteria, whatever.
Well, I don't know if it's 2 criteria. It's that the groups are not the same size, which affects the chances of being selected. If we went back to my earlier example where I said pretend there were 4 in each, if there really were 4 in each row, everyone would have the same chance of being selected. Everyone would have a 1 out of 4 chance of being selected. So it's really just, does everyone have the same chance? It's more the issue here when I ask if it's random. But because my rows are not evenly, you guys aren't evenly spread out, these ladies over here, they're in luck. They have a 1 in 2 chance of being selected. They're much likely to be in my group than anybody else. Well, you guys too, because Nick could be in your group. So that's what stratified is. You divide it into groups and take some from each group. Yes, ma'am.
And the groups don't have to be even, because it's saying you could do it by age, gender, income, so it's gonna leave lots of
Oh, right. They do this all the time, especially when they're taking polling results or by counties. There's some counties in the state of California that are much bigger than other, and they take some people from each county. It's not really representative because you know, Contra Costa County has so many more people than, you know, Humboldt County, whatever, how many people up there. So the groups don't have to be the same size and nothing, so they're taking some from each. Which automatically, unless the group happen to be the same size, it won't be random. It happens all the time with the states of the United States. If you take some people from each state, you guys do not have the same chance of being selected as people from Alaska. There's a lot less people in Alaska than in California. So the chances of you being chosen out of California is much different than somebody in Alaska being chosen because there's so fewer people up there. But they still would be doing a stratified selection by taking some out of each group if they divided us by states. Now, read cluster, and we'll talk about the similarities and differences compared to stratified. Who wants to tell me the difference? Yes? Go ahead.
Well, there's divided into groups, stratified, you're divided into groups and one person's chosen from that group. Whereas a cluster, you're put into clusters and the cluster's chosen rather than the individuals in the cluster, right?
So let's say it again. So they both are groups. It's confusing because one says groups, the other one says sections or clusters. It's groups. There's groups in the first one, a section or a cluster is another group. So they both divide people into groups. Stratified that we just talked about takes one or more. We could take two out of every group if we wanted. We take some from each group. So if I wanted to take two out of here, two out of here, two out of here, I could do that. That would be stratified. But cluster divides you into groups. Let's keep you in the same groups I have you in. And then randomly picks the entire group. Like I might roll my dice again and say, I want everybody in this row, everybody in that row, and everybody in that row. You take the entire group. That's what makes it cluster. So you're taking this large chunk, but you guys are tied together forever. If I pick him, that means I got all of you because you're all in that one group. So stratified is some from each group, and cluster is some entire groups, but not all of them. Lots of vocabulary the first week. We'll start doing some math eventually, and then you might wish for the vocabulary again, I don't know. By the way, I'm never going to quiz you on definitions, but I'm going to ask you to recognize, is this cluster or is this stratified? Is this discrete or is it continuous? That kind of thing. Questions on the differences between those two? And then finally, multi-stage is some combination of those ones up above that we just talked about. So maybe you're going to divide into cluster and you're going to take some from, or excuse me, you're going to do stratified and you divide into groups and you're going to take some from each, but the way you're going to take some from each is systematically. So now that I put you in the groups, I'm going to take every other person, right? That would be a combination of systematic and stratified. That would make it multi-stage. Lots of different ways. You think statistics is all about numbers, but a lot of it is how do you get your group, your sample to begin with, to not have any bias, to make sure that you represent the population so that now you can actually answer all your questions.